Okay, so now let's talk about some more advanced query language concepts. In particular, I want to begin to look at query operators of various kinds. The first operators we'll look at are comparison operators. You can find a complete list with links to reference material for all query operators in the MongoDB documentation here at docs.mongodb.org. We're going to do an overview of each type of operator with some very concrete examples. As always, the best way to learn is to get your hands dirty. As part of the curriculum, we'll have you do a number of exercises that give you quite a bit of experience with these operators. So as I said, we're first going to take a look at comparison operators. Now, these are operators that allow us to, rather than simply doing equality matches, match on the basis of a field's value relative to some other value. So as you recall from our movies collection, for each document we have a number of fields that detail various interesting pieces of data about each movie in our collection. One of those fields is runtime. And this makes a good starting point for considering some comparison operators. So here, we're going to look for all movies that have a runtime greater than 90. Runtime is specified in minutes, so this is all movies longer than an hour and a half. And taking a look through the results, we see that, indeed, runtime 135, and so on if we look up through the results. If we like, we can actually project out just the title and the runtime, give us a quicker summary of this result set. And you can see that every document in our result set does in fact have a runtime greater than 90 minutes. Now, let's revisit the syntax just for a minute. So, why is it structured this way? Well, the idea here is to maintain consistency with quality queries. So here, we're specifying again a field and, if you will, a value that that field should have. In this case, the value expresses a relationship that this field should have to a specific number. Only in this case, instead of specifying a value we wish the field to be equal to, we're instead expressing the type of relationship we want all documents in the result set to have with respect to the runtime field. Now this syntax also makes it very convenient to express ranges. So for example, I can stipulate that I'd like to see movies that are greater than 90 minutes long and less than 120 minutes. $LT being the less than operator. And in fact, what I really want here is I'd like it to be greater than or equal to 90 minutes and less than or equal to 120 minutes. And once again, let's project this out. So going back here, and here we can see we've lost a few results from the last time because now we're specifying that we want movies in a range, only up to 2 hours. Now, of course, with comparison operators, we're not limited to working with a single field. We can easily work with as many fields as we need to using any combination of comparison operators, any other type of operator, and equality matches. So suppose that we're interested in movies that are highly rated, but also very long, relatively speaking. And let's mix things up a little bit more by using an embedded document field, the tomato meter. Remember the max is 100. And we're going to combine this with looking for a runtime that's greater than 3 hours. Okay, so again, highly rated movies using the tomato.meter field, and very long movies using the runtime field. And here we can see we do have two results that meet this criteria. Godfather Part 2, of course, being very long, and in my opinion, the best of the three Godfather movies. Okay, so let's take a look at what other comparison operators there are. So, $EQ has exactly the same semantics as the equality matches you're already familiar with. We've looked at greater than or equal to, less than or equal to. Now, let's take a look at not equal to and $in. First, we'll look at $not equal to, or $NE. In a lot of applications, particularly if we're doing something like data cleaning, we might be interested in partitioning our data because we know we have some fields that are maybe not as expected. Now, a lot of movies in this collection have for rated a value of unrated. So maybe we just want to look at all documents that have an actual rating. So PG, PG-13, R, etc. I'll project out just a couple of values. Now, one thing I should mention about the NE operator is that in addition to matching all documents containing a rated field whose value is something other than unrated, this operator will also return documents that don't have a rated field at all. MongoDB supports a flexible data model, so it is possible, there are many use cases for this, for documents in the same collection to have fields that other documents do not. So in MongoDB data models, typically, rather than store a null value for a field, we will often simply not store that field at all. And we have a variety of ways of distinguishing documents that simply do not contain a given field. This, of course, being one of them. Now, the last comparison operator I want to look at allows us to specify a number of values, any one of which should cause a document to be returned. So in this case, what we're saying is, give me back all documents where the value of rated is G or PG. If we wanted to extend this, simple enough, we simply add another element to the array value of our $in operator. So please do note here that the value of $in must be an array. Documents that have a value for rated that is any one of these three values will be returned. So projecting out just title and rated, we can see that these documents do in fact match our criteria. And if we mix this up a little bit, and let's change this to just be movies that are R-rated and PG-13, you can see that now our results are matching those criteria. Now there's also an operator that allows us to do the reverse of what $in does. I'll leave that as an exercise to you to experiment with that operator. We've covered the comparison operators for doing queries within MongoDB. These are largely what you would expect from the list of comparison operators, and these significantly expand the types of queries that we can do against a MongoDB collection.